Hi everyone, welcome to the new SAF community stand-up. In this case, the subject is load balancing. Um, in this case, what I'm going to explain, it doesn't only apply to XAF, it applies to basically any .NET application that you can host in any of the OS supported by .NET. So today is only me. I think Javier will be joining later, and Dave is only listening mode, so he's here in the meeting, but he will be only active in the chat. So um, let's see. Let's start with what we have for today. So let's see. We are recording. So let's share the screen. And today we're going to start with a presentation. So let's see how Zoom will work with this. See. Good. So let's see, let's go back and let's start. Okay, so today's topic is load balancing Blazor applications with Apache Webserver. Actually, you can do this with many web servers and many technologies. You can even load balancing with .NET, .NET in front of .NET. But this is what I'm going to explain today is the most common use case. And it's a really stable technology that we are going to use also. So I've been using Apache web server for, I don't know, 20 years, something like that. And so far, so good. It's kind of the best server that I ever use, the one that I like the most. I know that some people like Nginx, and Nginx is also a really good product, but the difference for me is that I've been using Apache like kind of all my life. And it's there and it's working fine. Nginx is like a kind of a new iteration of web servers. It's kind of the most modern of all of them. Like with Kestrel, Kestrel is a really modern web server. So, but in this case, I will prefer stability and something that you have a lot of documentation. So that's why we pick Apache for this case. So let's see. What is load balancing and why do you want to use it actually? Especially in cases where you only have one server. So load balancing is kind of the process of distributing the requests of the servers. So imagine that you have two application servers, and then you have like 200 users. It will be nice if you can split that load between each of the servers, right? So that's the concept of load balancing. You send some requests to server A and some requests to server B. And why do you want to use this? Well, it's like having extra tires in your car. If you have 4 tires, you can actually use your car and drive through. But if you have 6 wheels, for example, you can lose 2 wheels and continue going like going on your way. So that's the idea behind the why of load balancing. And in the case of XAF, there is another why, which is there is some problem with the threading and the model locking. So if you split your load between two instances, the model locking is less likely to happen. So that's another plus of using load balancing. And basically makes your application a little bit more resilient in general, even if you use just one server. And we will see the case on how to use this. So there are two key concepts which are really kind of funny in the way that they are basically the same. The two key concepts of load balancing are forward proxy and reverse proxy. So basically both are proxies in the sense that you have your application and you have your user. So your user will request to your server something, and that server should forward that request to your application. And the same goes the other way around. Sometimes your application want to communicate with the client, so you need the reverse proxy. You need a way that your application sends the request to the server, and it knows to which client to send it. So you need both type of proxies. So the concept of load balancing is basically using these proxy concepts and put them like several of them together. So it's something like this. This is the original idea that you have the users, you have your server. In this case, this black thing in the middle will be Apache or Linux box or something like that. And then that Apache web server will have a proxy and a reverse proxy. And this here in the left side is your application, or as many applications as you want to have. So this is just the idea of a proxy, and we use it a lot when we host SAF application on Linux. Basically, what we do is we put here in front the Apache web server, and then we just do a normal proxy to a SAF application. In that case, is one-to-one. You have one virtual host on the Apache web server, and you forward that to one specific application. In the case of load balancing, it's basically the same idea. The difference is that instead of having one set of proxies, you have as many set of proxies as you want. So that is the same. You have your users, you send a request to Apache. Now Apache decide what to do with the request. And there are several splitting algorithms, and also that will depend on the server. And that I forgot to put it on the presentation, but I should have created a slide for that. So the idea is that once your request is in the server, in some cases you will use the most simple case, you will use round robin. So it means that you will be sending one request to each server. In some other cases, you can implement some logic there in the sense that you can tell, okay, if you're in this IP range, go to this proxy. And if you're in a different IP range, go to a different proxy. So, but the most simple case is kind of round robin. So that's what we are going to use today. Well, there are some small changes that you need to do in your Blazor application. So in your Blazor application, the idea is that since we have to have two applications or more than two is like good enough, but you can have 10 instances. Each application should listen in a different port. So in the end, how do we do this? We do this by adding the Kestrel section on the app settings.json. So in here you can see the configurations of my two applications. One is running in port 8080 and one is running in port 8081. And this I would like to show you. Let's see. Let's see if we have everything in the meeting. Okay, so let me show it here. Okay, you will see a lot of these black screens on this presentation. So here I'm connected to my Apache web server. This I hired yesterday in Linode. It's like $5 server, so I'm using just for testing. So in here, I have two folders. You can see the folder test1 and the folder test. If I do all this here, you will see that this is not a SAF Blazor application because that's in another folder. I will show you that later. This is the most simple Blazor application that you can find. File new project, you publish to Linux, and that's it. So if to make sure that I can have several instances of this application running, the idea is that I have to put it in different ports. So if I do nano and I read the settings, you will see here, this will run in the port 80. So let's exit this. It's clear. And let's run the application. To run a .NET application that is self-contained, in Linux, you just do something like this. Basically, it's just the name of the application. Forward slash and dot forward slash and the name of the application. So in here, these are the details of Kestrel. As you can see, this one is running in the port 8080. So now let's go to folder one. They are both in the same server. I can show it to you because I can go back a folder and do ls. So you see here you have test and test one. So let's go to test one. Okay, so in here it's kind of the same. We can do nano, the settings, location, and this is running in 8081. So when we leave here and then let's run the application, it will be Blazor up. And see, this is running now in 8081 and this is running in 8080. So, so far so good, right? We have two instances of exactly the same application running in Linux. So let's see, let's check the chat. Any questions so far? If there is any question, you can just write it in the chat and I will go back. I will be checking like back and forth to see if we have something that we need to address. Okay, thanks, Dave. So let's see, we have two applications running, right? So let's go back to PowerPoint. Yes, this is super fun with one monitor. Okay, so this section you can just copy and paste it in any Blazor application or ASP.NET Core application, and will work in all of them. You don't have to change anything in your code to make it work. And this is how you ensure that you can copy several times in the same folder. You just go and change the port, and then you have several instances of this application running, as I showed you before, like in the console. So now the beautiful part of using the console to set up all of this, these are the Apache modules that you need to have running in your server in order to make. Basically, the idea of proxy and load balancer is kind of the same idea. So see, in the list of modules, you have proxy, proxy HTTP, proxy balancer, and these last two are kind of really, really important. The LB method, basically, it tells you based on which method you will split the connections between the possible applications that you have. And the last one is also even more important, I guess, is the proxy for WebSockets. As we all know, like Blazor applications, they use WebSockets or SignalR in this case, or SignalR use WebSockets to communicate with the UI and basically rephrase the changes and have a copy of the DOM and update the DOM of the application. So if you only have like kind of a static or server-side application, for example, a PHP application, or if you have a Blazor application that use server-side render, like in .NET 8, those applications exist that are like kind of PHP type of applications that are rendered on the server side without any similar connection. You will need only the top modules for those. If you're using a Blazor server application, you need to include the WS tunnel proxy. Okay, so after we have set up the modules, which is basically these lines here, you can copy one by one and run it in the console, and that's it. Kind of boring. And then your Apache web server, if you have a default setup, will have the default configuration in this path, in this etc Apache 2 size available, and then you have the 000 default conf, which is the default configuration for the main website of your Apache web server. So once you open that that file, what you will see is the next part, which is that's the proxy configuration that you need in general. So as you can see, we define a proxy, and then you add a balancer member for each application that you have. As you can see, for example, in here we have balancer member, and then we have the URL where the application is running. So as you remember, in the console, I have one running in 8080 and one running in 8081. And here the LB method is by request, but there are another set of options that you can actually use to include like WebSocket affinity. that this load balancer is totally fine. It will work with server-side render applications, but it will have a problem with Blazor because of the signaler connection. So this basic setup doesn't work for Blazor server, only for Blazor server side, which is .NET 8. Okay, so after that, after you add this configuration, you just need to restart your Apache like with the last line. So let me show you that in the console. So here we have these two applications running. And now let's, I think I have this here. It must be here. I have edited that like 100 times since yesterday because I was having a problem with my computer. So all my deployments were failing. And no, I don't have it. So let's copy from the slides if it's possible. So I need to do sudo. Okay. So we need sudo nano etc apache 2 sites available, then 0 something. And I think this is the, yes, okay. So this is the full file. This is what you will see in a normal Apache configuration. So the only thing that I added here are these lines here, the ones that I show you in the presentation. Everything else was there by default. And if we remove these lines, what it will happen is that instead of doing the load balancer, it will basically render the files that are in this folder. So if I want to add some other node here, basically I just copy this line and add a new line underneath, and that's it. You can have as many as you want. So let's exit this. Let's go back to Zoom. Let's see if someone is need help with the presentation so far. Let's see the chat. Okay, no, everything is clear as water. Okay, so that's what we have there. So we have the basic configuration, and that will work for most server-side renderings. So let's see.
Sorry, may I ask a little small question?
Yeah, as many as you want.
Regarding this picture, you talked about that we should have different ports on each instance of application, right? But this is only in case when they are hosted on the same physical server, right? If they will be hosted on different servers, there is no requirement to run them on different ports.
There is no requirement to have it in different ports. The idea here about having this in the same ports is because basically what we want to is, especially this doesn't make so much sense because we're hosting this in the same server. But the idea is that for an XAF application, if you know that there is a problem with the model getting locked when you have too many requests, so this will help you with that. With this, you can, in a single server, host a lot of SAF users for SAF applications. Because if you have 100 users in a single instance of the application, all of them, when they move from view to view, they will lock the model and the application will become crazy slow. But if even you have the single server and you have this setup, you can add 10 instances of the application and you will not have the model locking problem because it's less likely that it will happen because there will be less people per application. So even like that makes sense. Usually you want to also plan your load balancing. Maybe you just have so many users, and you just have to have 2 other servers hosted somewhere else, and then you put the URL. So what you need there is the URL. The ports are not necessary. It's just for the case that we have that. It's a single server. Okay,
Okay, got it. Thank you.
but really good question in general. So the next thing that we need to think about is, what about WebSockets? Is how do I forward those? And basically, it's kind of the same idea. So if we go back here, see the proxy set LB method is by request. If we want to use WebSockets, which means we can host SignalR connections, you need to change sticky sessions to, I mean, the proxy set will be sticky sessions and route ID, which means that if you make a connection to one of these balancer members, your SignalR connections will keep still going to that specific instance. Because if it's not, what will happen is that depending on the algorithm that you have, like round robin, for example, that will split equally between instances, your request might start a SignalR connection with one server and then end up in a different server. So if you want to use Blazor applications, this is what you need to do. Basically, set the proxy set to have sticky sessions, so your SignalR connection will keep on the same server. Okay, there is another step also. So also we need to have the rewrite engine on for to enable SignalR connections or WebSockets. Basically, this rewrite engine, what it does is it takes the request from one URL and rewrite it as if the request was done to a different URL. So in here, for example, you see that the URLs are being rewrite if they start with the WS, which is the WebSocket connection, or if they have the HTTP type of connection. So as you know, when your client connect to your Blazor application, they may basically do connections. Once to the HTTP server, which is what renders the application, and then you make one SignalR connection, which is the WebSocket connections here in this picture, to control the state of the UI of the render of the DOM. So these two parts are necessary to host applications that use WebSockets in general. This can be also chat, for example. It doesn't have to be Blazor exactly. It can be something like just a SignalR chat or any type of real-time framework that there is a lot of them in JavaScript. So for any case, you will need something like this, the sticky sessions and the rewrite for the sockets, the rewrite engine. So, well, that was all for this presentation. So if you want to see this site running, you can go to, I have it here. So this, you can put this in the chat, for example. I will put this in the chat so you can go and take a look to it. That's the URL of the application. And in this case, the application is being load balanced. So as you can see, it's kind of really simple. You just need to know why you're going to do it in some cases. And I mean, how we're going to plan to use the balancer. And there is one other thing that is kind of really important. Right now, if I go here and if I kill any of this application, my load balancer will be like, missing one instance. So what will happen is that the request that goes to one of the instances will succeed, and some of the requests will fail. So you will have this strange behavior. So this is, I don't know, what I'm doing here is that basically I started the applications manually, because if I kill this now and if I go here, this will see service unavailable. So if I go here and let's on one, let's see what happened. Some of these requests will fail, some not. Okay, all of them are going to the same, so that's good. I guess because run robin see only like one instance. So if I want to have the other one, then now they can do the balancing again. So as I told you, this is kind of a no what I'm doing here because I'm starting the applications manually. What will happen is that if the application crash, there is no way to restart it. I mean, there is no service in the background trying to respin the application. So that's what web servers do in general. They have this isolated process that they can control, that they can stop and start. That's basically what web servers do. And let's see. In this case, there are some things that you might find interesting in general. So let's go here to the presentation. I will share these slides. Actually, let me share them right now. Let me put this. Okay, so there are a few interesting resources in this PowerPoint. So first one is if you are running .NET applications, Blazor applications, or ASP.NET Core applications in general, in Linux, what you need to do is basically host them as services. So for example, this is an application that I created, is a XAF application. This basically writes all the service files needed for you to host your applications as services. So for example, what we have is called, let's see, it's called Blazor app. So this is the name of the application. This is the assembly name also. And I will leave that as it is. It's self-contained. And the user that I want to run it on is this one. So in here, what you can do in general is generate the files, and it will generate a zip with all these files here. So let's go through the files really like one by one. So here, basically, this is the service description. It tells you where the application lives, where is the working directory, and this is kind of the important part. If the application crashes, it will be killed, and then it will be restarted in 10 seconds. So it means that if you have like those two instances running and one is killed and you have them as a service in 10 seconds, that instance will respond, create a new instance. So this is really needed in general to deploy applications, because in this other case, as I show you here, if I close the console, the process will finish. So your instances will go down in that case. So this is a little script to just add some missing things and then change the permissions and install the service, and you can enable start or see status for the service. The uninstall script also, the service status here, there is a stout. Here is a typo. And then to start and stop the service, you have like all these commands. So if you want to deploy an application to Linux, basically you can write this file yourself. I got this from the .NET official documentation, but I hate to do it by hand. So I always do it here, and then I generate the files, and then you can see the service files here. So here are the instructions, the each command for the status for start and stop, and for install and uninstall. So that's something that you kind of need to do in general. That is required actually for making a real live example or scenario. Okay, so the other one that is really interesting is this one. Let's copy this one. I base my example on this example actually. So this is how to use Kubernetes in Blazor. So the idea with Kubernetes is basically the same. The difference is that they are using an Nginx load balancer instead of an Apache, but that's kind of the same. So the main difference between my example and this example is that this one is orchestrated. What does that mean? It means that in my example there is no orchestration, which means that in here it's so simple that if I kill the process is done. There is nowhere to respin it, and I can fix that by creating each process as a server, as a service. But still, what will happen is that even if we have one single user, we'll have a static set of uh, of applications running. For example, in here, we know that we have these two, and there can be no user, and you will still have those two. So there is no orchestration. This will not grow or shrink depending on the users. They will just be split between those two instances. There is no nothing else. So in the Kubernetes example, the difference is that this is orchestrated. If you have one user, you might have only one instance, but if you have 10,000 users, you might have 100 or 200 instances, and they will scale up and down depending on your needs. So this is good. This example is good for costing. They basically do the same. The difference is that here you kill the instances or containers if you don't have users connected to your application. So this is more cost. This example is done for kind of reducing the cost of spinning applications. And the last link that I want to show you is this one. So this one is the official documentation from Developer Express on how to deploy to Linux with Nginx. In my case, it's Apache. That's why I did Apache. I have an Nginx server also running for this meetup. But I thought, okay, Apache would be more interesting because it's not exactly here in the documentation. To be honest, I followed these steps and some of them didn't work for me. I need to double check all the deployment process again to make sure that in Linux is still the same. But this tutorial will actually work for most people. This Linux server that I'm using is kind of experimental, so that's why maybe some of the steps here didn't work completely. So that's it for today. It was really kind of short example. We have two other examples to show you, but those will be in a different stand-up. One is for Azure, and there is a way to do load balancing in Azure. And the other one is Nginx, but that's almost the same example as the one from Apache. The only difference is that the Nginx file is different. That's the case. So, any questions so far? Something that you want to share? What is your experience with load balancing, for example? Or if you want to implement this in your office? Let's see the chat. Well, it looks like everyone is really quiet today. This happened in the Linux meetings. No one.
Just want to say thank you for this nice presentation.
Oh,
And if you will write the corresponding blog post, which will cover your
yeah,
it will be highly appreciated also.
yeah. Actually, I will add the blog post so you can have a copy of the files because the files are really simple. Basically, just copy and paste some and replace some values, and there you're kind of good to go. So it's really easy to experiment with this. It's 10 lines, or I will make a video of like taking a server completely new and paste the commands. There are like 15 commands, so it's kind of really easy. It seems more critical in general, but it's not. Let's see. Okay, so they also have a question is that, well, with this, what happened regarding the model is that you have the well-known issue with the model that it gets locked when it's being written. For example, if there are 100 people and they are moving from view to view, each time you move from view, you lock the model and you write it. So that's what makes the application slow. It takes time for them to process the request because you will not process the next request while the file is locked. So something like this, if you have like 10 instances and then you have, for example, 10 users, it means that they will go one for each instance. So the locking problem will not happen in general. And if you have 20 users and 10 instances, still the problem might happen, but they happen if both are changing views at the same time. So it's less likely to happen. So this load balancers scenario, what they do in general, they don't fix the locking problem. They make it less likely to happen because the more instances you have, the less likely to happen because there are less users per instance. So that's also the idea of having all of them in the single server. Like it doesn't make sense if you want to balance CPU and RAM resources because all of the instances are running in the same server. So basically you're sharing the same resources, same CPU, same memory. But the idea there is you will avoid the model locking problem. Imagine you have like kind of really big Linux server, like 50 gigabytes of RAM, 12 cores. That's what you need for a SAF application. They don't use so much CPU resources. But what you need to do is basically avoid the model locking problem. And you do that by doing the load balancing. And there are other ways also, but you will lose some functionality. In this case, you don't lose anything. So that's the good thing about the load balancing idea when you use SAF applications specifically, that you will basically cheat the model locking problem. Okay, so I think that's the dog is here. That's everything for today. Thanks everyone for showing. I know that we moved this from Thursday to Wednesday, but tomorrow we have another another stand-up. And I will put the files for this example in the Facebook group. So again, everyone, thanks for coming and see you on January 2024. Bye, take care.